Let's give it a couple of minutes. If you have any questions on the homework, I'll be happy to answer. There was one email this weekend, and it was a very good question. It was a I don't remember the problem number. It was a multi-part problem where basically you had to, it was a prize, a lottery, a prize, problem number 9. Okay. Yes, I think that's the one. Where you had to calculate the price, you had to calculate the rate and then take that rate and apply to the second part of the problem to calculate future value. And you would not get, because the connect is asking you to input the answer for part A, or first part, as what you call 2 decimal points. Then you take that, the same number in 2 decimal points, you input it as I in your calculator and calculate future value, you get an answer that Connect is not accepting. Your answer is correct, by the way. The problem with the Connect is, for the second part, Connect does not want you to round the interest rate. So this is what you do. If you still have a problem, if you have not figured it out, calculate the interest rate for part 1, whatever it is, and calculate that interest rate, and then you put your answers to Connect, but then you do one of the 2 things. You take that interest rate and expand the decimal point. Take it from 2 or 4 decimal points to 6 or 7, as many as you can get. And write that number down with the 6 decimal points. That's the number with 6 decimal points that you input into your calculator as I. And then you compute future value. That's one thing you can do. Or when you do part A and you get your answer, you compute I and gives you 7.72, for example. This is what you do. Don't clear it. Don't clear the calculator. Leave the number as it is and input that number again as I. So whatever is on your display for part A, input it for part B as I, then input other variables and compute future value. So you can do 2 things. When you get the answer to A in calculator, leave it in the calculator, don't clear the calculator, and then input that answer as I, and input other variables to calculate future value. Or you do the interest rate that is computed in part A, then go ahead and change the decimal points to see what the number is with 6 or 7 decimal points. Write that number down, then use that number to input as interest rate to calculate future value for the second part. You will get the answer that way. It's just a bit tricky, and it's because of the Connect and the confusion that it creates. If I were Connect, I would have said enter the number in 6 decimal points. So this way you use the same number you entered for part A, you use that number to do part B. But unfortunately, that is not the case. It's asking you to enter it as 2 decimal points. I hope that's clear. If not, drop by during office hours, and I will show you.
Are you going to curve the grade for that one?
There is no curving. There is absolutely no curving for any grades in homework, exams, or anything, except if things get really bad in the course grade, then I will curve the course grade. But individual items are not curved, so you are getting what you are seeing. Okie dokie.
If you already submit, Professor, can you go back and try to?
Yes, you can submit 3 times.
Okay.
Yeah, go, and I always get, I will always ask for the highest grade of the 3 submission. Whichever is the highest grade, I will take that.
Thank you.
Sure.
Wait, so like if we get like one mistake, then we have to do like the whole thing over, or it's just like that
The
one?
way set up that the way I have set it up, all your answers stay. The only thing is what you change. You see what I'm saying? So all the questions, your answers stay. If they're correct, they're correct. That this particular problem, you can go back and change your answer. If it doesn't work, let me know. That's important. Okay, okay. All right. I'm glad we talked about that, because to remind you that your homework is due on Wednesday. Don't wait till the due time, which is 11:59, a minute before midnight. Don't wait till then, and give yourself some time, just to make sure if there's discrepancy in hours, in the time between your time and the Connect timekeeping, you will be. Okay, Luke, you should be able to check your work as many times as you want. Yeah. And you can save your work as many times as you want, but you can only submit for grading 3 times. So please turn in your on time and do that. And Eric, that's a good reminder. Eric is asking if we are going to go in person next week. That is what is expected. I'm going to get confirmation today from school to make sure. But as of today, I have not heard anything to the contrary. So please mark your schedule that you have to, we will be meeting in person. And as this continues, remember that we will be taking the test in class as well. So be prepared to do that. And also, there were a few people who were using DRC services. I reminded you on the first day we met to go and see, basically make arrangement for the test. Yes, Anthony.
Hi, is it still the same room number and everything? One
Yes.
building 162, room 10. Okay.
Yeah.
Sweet. Thanks.
All right. Okay. The problem is now to get the parking recap. Okay. I'm also hoping that this cafeteria and the dining services will be available for coffee and that sort of thing. I don't know if they are open or not. I have not been back on campus since 2019. So let's see what it looks like. All right. I'm going to share my screen with you. Notice chapter 5, I dealt with.
Wait, I have a question actually.
Yes.
How do we expand the decimals to like 6?
It is calculated guidelines on Canvas, but which one do you have?
Texas Instrument.
You use the second key.
Second key.
And the dot in between 0 and plus and minus key. If you press that, it will give you DEC, decimal.
Okay, then you change the 6, right?
Press 6 and enter. There is an enter key on top of the calculator.
Oh.
And
Okay.
you see that decimal points increase.
Okay, thank you.
But
Professor?
technically bring it back to 4.
Mhm.
4 is good enough. For this particular problem, increase it to 6 or 7.
Professor,
Yes.
I just redid problem number 9 and into the 4th decimal place, it gets the right answer.
Oh, to the 4th, it does?
Yeah.
Okay. All right.
And
That's cool.
when I submitted on McGraw-Hill, McGraw is taking the average of the two, but do you just take the highest one?
It shouldn't take the average, but Let's wait. When I retrieve the grade, I will ask for the highest one.
Okay.
You keep track of that grade. When I submit the grade, you can check and see.
Okay.
Okay, just remember to do that. But in the past, I always retrieve the highest one.
Okay.
Yeah. I don't know why they would do that. Okay. All right. We had one. This. Okay. Yeah. I keep forgetting you. Sorry about that. Basically, what we will do is in chapter 5, we had present value, we calculated future value. We had future value, we calculated present value. We had 2 cash flows at the beginning and at the end of the whatever the period was. Chapter 6 is more realistic. Chapter 6 says, what if you have a series of cash flows? Cash flows in year 1, 2, 3, 4, 5, 6, and on. How would you do present value and future value? Now, to facilitate the answer, technically you can do chapter 5, apply the rule, and do the present value or future value for each cash flow. Do future value cash flow in year 1, find how much it is that in year 5, in year 2, in year 3, one by one. That will take you forever. So we will deal with the shortcut. To start the lecture where you have multiple cash flow, this is chapter 6. Now we are dealing with multiple cash flows, meaning you should be able to see my lecture here. We are dealing with multiple cash flows, where cash flows are paid in year 1, 2, 3, 4. But we will make a simplifying assumption, and then we will make it more complicated. For now, before I start, let's deal with an issue I brought up in chapter 5. Technically, when interest rate is given to you, it is stated in annual term. So wherever you see an interest rate, whenever you are quoted an interest rate, all right, wherever you read about an interest rate, you're talking about annual interest rate. Okay, you probably have heard in the news that the Federal Reserve is going to raise interest rates 3 or 4 times in the future. I'm sure you have heard that. Okay, you heard that Federal Reserve will increase interest rate probably by 0.25%, a quarter of 1%. What does that mean? It's a quarter of 1% per year. They are not saying per year, because it is implied. Interest rates that is quoted to you verbally or in writing, or if you see it, they are all annual. However, interest rates can be charged more frequently than annual, more than once a year. They can be charged semi-annually. You can see on the screen. Semi-annual, that means twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, 52 times a year. Daily, 365 times a year. Practical examples, your home mortgage, your automobile loan are monthly. Interest rates are compounded monthly. Whereas your savings account, interest rates are either are compounded at the fraction of 1 second. Your credit card company charges you daily interest rate. Okay, so you can have frequently compounded or discounted interest rate. How would you make the adjustment? Now, you can do that on your calculator. I'm not going to show it to you. If you are interested, come to office hours. I will show it to you one by one person at a time, if you are interested. The reason is that if you change the setup on your calculator to semi-annual, to monthly, to daily, you have to always remember to change it back, because the problem will have different compounding setup. So you have to change that compounding factor back and forth. And I don't trust you that you will remember to do that. So this is my strategy. If you don't like it, as I say, come to office hours and I will show you how to change the setup on your calculator. But I think most of you will agree with me that you can do that adjustment manually, meaning take the interest rate, as you can see on the screen, take R divided by M, and take T, multiply it by M. So if it says interest is compounded quarterly or 12% compounded quarterly, take 0.12 right here. 0.12 divided by M will be 4 because it's quarterly. And take the period, 5 years, multiply it by 4. And that will take care of it. So you keep the calculator as it is set up right now on annual basis and adjust the interest rate and the period manually yourself when you input it as I or as M. Okay. To do that, remember M is 2 for semi-annual, is 4 for quarterly, is 12 for monthly. I don't have weekly here, but is 52 and 365 for M. But if it's more than hourly or per second, if it's continuous, then you see this word here, continuous compounding. Continuous compounding means at the fraction of a second. Then you use the exponential values here. But anyway, for calculator, take the interest rate divided by M, whatever that value is, and then press I. So take interest rate divided by M, then press I. Take period, whatever is the period, T, multiply it by M, and then press N. And that will make adjustment. Let me put these here. This one is here. Okay. What if you have continuous? What if you have continuous? Write it down. 10% for 10 years. Continuous compounding. 10% for 10 years, continuous compounding. If you're doing future value, this is what you do. Take R times T. Take R times T. 10% times 10 years equal, and you use exponential value, e to the x. If you look very carefully, that is key 1. So you do orange 1, that's e to the x. If you look at your calculator HP, and that will give you a value 2.718. Let me change that to 4 decimal points. Okay. Okay, that is your e to the power r times t. You multiply that by present value, or you can divide it into future value, depending upon what you calculate. For Texas Instrument is 10% multiplied by 10 years equal, and you do for the e to the x, you go second ln. You have a ln key next to 7. Next to 7, you have ln key. You do second key ln, and that's 2.7183. Notice both calculators give you the same answer. And that's E times R times T. That's to calculate future value. What if you're calculating present value? You can do it this way. If you're calculating present value, you can take future value divided by e to the power r times t, or you can do future value times e to the power minus r times t. Okay, so if I take 2.7183 and divide that into 1, I will get this value, 0.63679. But let's do this. Let's do this here on Texas Instrument. 0.10, that's 10% times 10 years equal, but they want me to change the sign to a minus. So I do change of sign, plus minus key, put a minus here, and do second function, ln. Check this out. 0.3679. Exact same answer, 0.3679. These formulas you will see in the formula sheet. Any questions? Okay. If you recall, I said at the beginning that I'm going to deal with multiple cash flows. To simplify things, however, I am going to assume that my cash flows are the same dollar amount, as you can see on the screen. But I'm also going to make another assumption as well. So here it is. Let's write this down. I'm going to deal with the situation called annuity. I want you to write this down. I will scroll back and you can write the formula. But for now, I want you to write down this definition. Annuity, which is represented by letter C in the formula, annuity is fixed dollar amount at fixed interval, $100 per year, fixed dollar amount at fixed interval, $100 per year, paid or received at the end of each interval. That is very, very important. All three conditions must exist for you to have annuity. Fixed dollar amount at fixed interval, $100 per year, paid or received at the end of each interval, at the end of each year. Then the cash flows are called annuity. And if that is the case, if you have annuity, like in this case, these are the formula. This is the present value of annuity formula. This is the future value of annuity formula. By the way, if you like, go ahead and write those down. You are not going to be using them. You are not going to be sitting down and calculating this bracket. I don't think you will. If you want to, that's fine. I don't have a problem with that. But I don't think you will. You paid money, good money, to buy the financial calculator. And we are going to use that function, the financial calculator. Okay? But the important thing here is you have $100 in year one, which notice is paid at the end of the year. You have $100 in year two, the same interval, is paid at the end of year two. $100 in year three, paid at the end of year 3 and 4. Now, let me ask you a question, and I want an answer from you. Okay? There are 111 of you supposedly in this meeting. So one of you, be kind enough to answer me. Do you have an annuity now? You still have, Pardon me? You still have $100 a year for 4 years. Okay? But do you have it at the end of the year? No. It's $100, first $100 is at the beginning of year one, not the end. Second $100 is at the beginning of year two, not the end. You see what I'm saying? The last $100 is at the beginning of year four, not the end. So the answer is no, you do not have annuity. These formulas will not work. This is what I'm leading to. If you don't have annuity, the formula will not work. Let me ask you a question. This time I will wait for an answer. Do you have an annuity?
Nope.
No. Why not?
Because in year 3 you didn't get your $100.
Exactly. Very simple. Okay. Now, let me ask you again. Let's say you get $100 in year 3.5. Do you have an annuity? You have $100. No, you're right. You have $100 in year one, $100 in year two, $100 in year three. So far, so good. But then you have $100 in year 3.5, and another 100 in year four. So you don't have fixed interval. You have fixed dollar amount. You have it at the end of each period, but they are not at fixed interval. So you don't have annuity, the formulas will not work. So for the formulas to work, you have to have annuity, and you have to have fixed dollar amount at fixed interval, paid or received at the end of each interval. C is the amount of annuity, is dollar amount. R is the interest rate. T is the period. The same thing for future value as it is for present value. One is if you save $100 a year for 10 years, how much money you will have after 10 years. The other one is how much money you should put in a savings account today in order to write $100 checks for the next 10 years. Right? That's present value.
Professor, I have a quick question.
Yes.
So you're saying, but going back to the example that you're using, you're saying, let's say you had $100 at 3.5. So, but if you're given $100 for every single half year, it would be an annuity because now it would be a fixed interval.
Exactly. 100% correct. Yes.
Okay, I see.
Okay. Let's deal with the situation where the $100 remain the same every year. They are at fixed interval, fixed dollar amount, but instead you're receiving them at the beginning of each year. Let's say this is $50 for year one, received at the beginning of year one in zero. $50 in one is the beginning of year two. $50 in two is beginning of year three. $50 in three is beginning of year four. Fixed, this is the definition. Fixed dollar amounts at fixed interval, paid or received at the beginning of each interval. That is called annuity D. That is called annuity D. The only thing that happens in this case, you add this last component to the formula, 1 plus R. you add 1 plus r, you multiply both formulas by 1 plus I, okay? Just, I don't want to drive you crazy, but I'm going to scroll up and look at the first part of the formula in black fonts. Present value annuity, look at that, and look at regular annuity. There it is. This is regular annuity. If I scroll down to annuity due, the first part is exactly the same. This part remains the same. The last part changes is annuity due. You add 1 plus R. You multiply it by 1 plus R. The same thing with future value. Look at the future value. Look at the future value annuity. The future value annuity T. In fact, I should be careful. I'm using T and N then. This is T. It's exactly the same thing, the same formula, except I multiplied by 1 plus R. Because from year 3 to 4, there is 1 year that I will earn interest. So I multiply that by 1 plus R. I want to show you something. If you recall, I said that you can change the compound. And I said, if you come to office hours, I will show you how to change it. But also you can do annuity and annuity due on calculator. You can change the mode. I don't want you to do that. I'm going to show you, but I don't want you to do that. The way you change it, is for 10B, you do the orange key and MAR on your calculator. Do this, do orange key, MAR. You see here at the bottom of the display, it says BEG. That means beginning. That means annuity due. By default, you don't have that. Look at your calculator, it doesn't have it. Unless you do orange key, MAR. You do it again, it will disappear. You want it to be at the end of the default. Then you do your calculation the way you do as annuity, but if it is annuity due, all you have to do is not very difficult. All you have to do, take your calculator answer and multiply it by 1 plus R, whatever that answer is. And you will get the correct answer. Okay? So the same here. If you look at this, this is regular annuity at the end of the period. But if I do second and payment, PT, second payment, and set, where is my set? Second, set, it says BGN. It will say BGN, beginning. And it basically, if you put any cash flows in there for the end of the period, for the beginning of the period, it will be treated as annuity due. But I don't want you to make that change. I want you to keep it at the end. I want it to be the end cash flow. I hope that is clear. So if you keep it at the end, and if the problem is annuity due, then you take the calculator answer and you take one extra step, multiply it by 1 plus R, whatever that is. I want you to write down this as a note. That is very important. Okay. Note 1. Interest rate given in any problem. Interest rate given in any problem is annual by default. You read the problem, you have done the problem, you have seen you are given interest rate. By default, you assume that is annual rate. That's per year. If that is not the case, I have to tell you so. I have to say either I have to say 2% per month Or I have to say, for example, 24% compounded monthly. So you get 22%, 24% divided by 12, you get 2%. You see what I'm saying? So I will either have to say the annual rate compounded monthly, daily, whatever it is, or I have to say this rate per day. If I say 5%, you assume it is annual, always, all the time. That's the rule. So interest rates by default are stated in annual terms. I want you to remember that. That can be one trick to a problem that you're solving on the test or the homework. All right. The second note, annuities, annuity cash flow by default are stated as end of the period cash flow. Annuities by default are at the end of the period cash flows. If I don't say, if I tell you $1,000 a year for 5 years, by default, you will assume that is annuity, which is at the end of each period. Okay, if you come and ask me, is this annuity or annuity due? I'm not going to answer. I say, you're supposed to know. So if I don't say anything, all I say is $1,000 a year for 5 years, by default, you assume this is annuity is at the end of the year. If I don't mean that, if I mean for it to be at the beginning of the period, I have to come out and very clearly state that. I have to very clearly tell you this is $100 a year paid at the beginning of the year, or $100 a year annuity due. I have to be very specific. There is no room for you to guess. If I don't say anything, by default, is at the end of the year, is regular annuity. If I don't mean for it to be regular annuity, I have to come clearly and state to you that it is not, it is annuity due, or it is paid at the beginning of each period. Do you have it done? Let's say yes. Okay. Please make a note of this. These are sort of, think of these as hints in order to solve the problems. It just makes it less complicated. Chapter 5, you had one formula. You manipulated it for present value and future value. So there was one formula to find future value, to find present value, to find the period, to find the interest rate. One formula. In this chapter, you have two formulas. One to find future value annuity, one to find present value annuity. But if it's annuity due, all you have to do is take either formula and multiply it by 1 plus R. So it's actually one formula. Okay? But you have to be prepared for special situations, and one of them is what I have here. I'm going to make a slight change in here. Oh, no, I have it. Okay, the frequency of annuity, interest rate, and period, notice in red font, must be the same. What does that mean? If interest is compounded or discounted annually, that means R is per year, C must be annual, N must be annual. So if R is compounded once a year, your C annuity must be per year, and period has to be annual. You cannot say $100 a year for 5 years at 10% compounded monthly. The formula is not going to work. You have to make adjustments. And I will show you what. I will show you the adjustments you have to make. But for now, this is what I'm saying. You read the problem, ask yourself, what is my annuity? It's per year. What is my interest rate? Per year. What is my period? Year. You're all set. They're all the same. Use the formula, use the calculator function. You will not have any difficulty. If the interest is compounded monthly, that is R is per month. Then your annuity has to be per month. C has to be per month, and T or N has to be per month. So if interest is compounded monthly, make sure your C is per month. What if it's not? Divided by 12. Make sure the period is per month, multiplied by 12, if it's not. So your R has to be compounded monthly, your C has to be per month, your N must be months. They all have to be the same for the formula to work, for the calculator to give you the right answer. Please, if it's not clear, let me know. I try to say it a different way. But that condition is very important, because if these conditions are not met, if your C, R, and N are not the same in terms of frequency, they're not all per year, they are not all per quarter, not all of them are per month, your calculator answer or formula answer will be incorrect. Okay, in order to get it right, you divide C, annuity, you divide it by M, you divide R by M, you divide N by M. M is the number of compounding. If it's monthly, it's 12. If it's daily, it's 365, and so forth. Any questions?
No questions.
Okay, thank you. So the formulas will change like this. Notice I said divide C by M, divide R by M, divide N by M. So the formula up here, this formula, you divide each variable by M and you multiply T by M. So this formula will look like this, the annuity due. I'm using annuity due because it's a longer formula. So is C divided by M, R divided by M, T times M, and remember, you divide R by M. Wherever you see C, you divide it by M. Wherever you see R, you divide that by M. Doesn't matter where it is. And then you divide and multiply T by M. But I should, to be consistent, something you have to learn to calculate, I think it's part of your homework problem. If I remember, I assigned the problem to do that, is that if you recall, I gave you a couple of two notes. I said, first of all, interest rates are per year by default. What if they are paid more frequently? They're paid every month, every day, every quarter, all right? So then the rate you are charged is different. Okay, if you have an automobile loan and your loan contract says 4% interest, you are not paying 4%. Well, how do I know? because your automobile loan is a monthly loan. The interest is charged monthly. The interest is compounded monthly. So that 4% that they're quoted in the contract is annual. So the rate you actually pay is higher because it's compounded more frequently. How much is it? You have to calculate. The law says, according to Truth and Lending Act, financial institutions have to quote interest rates as annual percentage rate. In other words, per year basis. You see APR, annual percentage rate. Okay, so if it's 2% per month, you take 2% times 12, APR is 24%. So the interest rate is coded on annual term to you. You always get APR. What is the actual charge? You have to calculate. And that is called effective annual rate. Effective annual rate, which is equal 1 plus APR divided by n to the power n minus 1. If it's continuous, the formula will change because n can go as far as 365 days a year. But if it is at the fraction of 1 second, we call it continuous, then you do e exponential value of r minus 1. Let me give you an example. I don't know how many of you know your credit card interest rate. My rate is 19.99%. So my APR is 0.1999. Okay. But the credit card companies charge interest daily. So my M is what? 365. So divide that by 365. Then add 1 to that. That's 1 plus APR over n. Take it to the power. That's orange key, multiplication key, to the power 365. You will get 1.2212, subtract 1 from that. I am paying 22.12. The credit card company quotes me 19.99%. That's the contractual rate. But in reality, if I make payments on my credit card, the credit card company charges me interest, and the interest, what they are charging me is 19.99. What I pay is 22.12. Should I be interested to know? There's a 3% difference here. Of course, I have to be interested to know. That is called 22.12 is called effective annual rate. What if it's continuous? What if it is credit card companies don't charge continuous interest? But what if it is? So if I look at my Texas instrument, 0.1999, that's 19.99, e to the x, second key, ln, subtract 1 from that. Effective annual rate is 22.13%, 0.2213%. So we are interested to know what the effective annual rate is, and you will see in a moment why also, but that is important to know. Look at the difference if it was monthly as opposed to daily. 0.19999 divided by 12 plus 1 to the power 12 if it's monthly. Holy shit. Sorry, I'm sorry. Okay. this doesn't make sense. 0.1999 divided by 12 plus 1 to the power 12. That's better. Minus 1. That's 0.2193. Monthly, the rate will be 21.93. Daily, 365 days, it will be 22.12. So there will be about 0.3% difference in the rate. So you can see. And if you have a long-term loan, something like 5 years or 7 years, that 0.3% difference is quite a bit of money. So you want to be aware of that. Okay, again, if you have any questions, go ahead and ask me. Let's deal with this. There are some special situations here we will discuss. We have annuities for a certain number of years. What if you have annuities forever? What if you have annuities forever? There used to be, not anymore, or you don't see it that often, British government used to issue bonds that had maturities of 99 years. That's almost forever, okay? They used to be called council, and they paid, the bonds did not expire for 99 years. Here, perpetuity is when you have annuity forever. You have $100 a year forever. That is called perpetuity. There is no end in sight. Couple of times, years ago, I tried to be funny, and I asked students to calculate the future value. And they struggled, they went back and forth, they sweated, and they came back and said they don't know what the formula is. And I said, there is no formula. How can you calculate future value of something that goes on forever? Where is that future value? To have a future value, you have to have a certain time period. So if it goes on forever, it's virtually impossible to calculate. So the students let me know how much they dislike me. So I have stopped asking the stupid question. So what am I talking about? With perpetuity, you can only do present value. You can only calculate present value as far as perpetuity is concerned. Okay, and the formula is you take annuity, C, your annuity, divided by R, interest rate, and that gives you the present value. Very easy. Very simple, very easy, to the point. You can also calculate the present value of a perpetuity if it's growing at the constant rate. That's very important. The growth rate has to be constant. So if you have an annuity that goes on forever, but grows every year at the constant rate, we call it a growing annuity at a constant rate. Then the formula is what you see in the middle of the page. Present value of perpetuity is C divided by R minus G. G is the constant growth rate. You can still calculate the annuity. You don't have annuity anymore. You realize that? So in year one, you receive $100. If the growth rate is 10%, in year two, it will be $110. In year three, it will be, in year one will be $110. In year two will be $121. In year three, it will be $133.10, and that goes on. Every year, this $100 will increase by 10%, as long as the change in cash flow, in annuity, is 10% every year forever, you can calculate the present value using that formula in the middle of the page, C divided by R minus G. So here you have annuity that grows at a constant rate, changes by a constant percentage. You may have a special formula. I don't know if I assigned homework or not, but be prepared for it. It is when you have a growing annuity for a specific period. It's not forever. If your annuity changes by a constant rate for a specific period, you have $100 a year growing at 5% for the next 10 years. Can you calculate the present value? The answer is yes. And that's the formula you see at the bottom of the page. These formulas will be given to you in the formula sheet.
Professor,
Yes.
quick question on those British bonds you talked about.
Yes.
You said they lasted for 99 years, so wouldn't you be able to put 99 for the year value?
Yes, you can. Yes, you can. But they are in real life, that is almost as close as you can come to infinity. So what I'm saying is that we don't really have to take it literally, infinity. Anything longer than 90 years is close enough to infinity, so we can treat it accordingly. But straight answer to your question is yes. Instead of infinity using like perpetuity, you can calculate it for 99 years. Let's, you got me curious. Don't you ask questions like this, you get me in trouble, you know that? Please write it down. Let's say the bond pays $100 a year for 99 years. And interest rate is 10%. $100 a year for 99 years, interest rate is 10%. I say treat it as perpetuity, which means you take $100 a year and divide it by rate 10%. That's equal to $1,000. That's your present value. Present value, that's on my HP. Okay, on my HP. Now, what if I have to do the formula for 99 years? I will show you in detail how to do it, but this is what it is. Let me clear it. $100 becomes every year your payment. I said 10% interest, and I said 99 years. We are computing present value. Look at the number. 999.92. The difference you see is about 8 cents. Okay, so we get pretty close. We get pretty close in terms of treating it as perpetuity. If I treat 99 years as perpetuity, the present value is 1,000. If I treat 99 years as 99 years, then the present value is $999.92. So there's 8 cents difference there. Of course, I'm saying that's not much, but remember, if you're dealing with $10 million, then that makes a difference. If the payments were larger, so the difference will be greater. Let's say that let's make the payments $100,000. I don't know why. Oh, God damn it. If instead of $100 a year, we get paid $100,000, let me change the sign so it will look Pretty. It is for 99 years. Is for 10%. That's the present value. And let's use the same 100,000. The same 100,000 and divide it by 10%. And I get 1 million. So if you look at this, the difference is $80 over 99 years. So the difference is still is not that significant, even if you're dealing with $100,000. I hope I answered your question.
Yeah.
Okay. Please write this complex situation down. This is what I'm talking about. This is, I want you to be prepared for situations where you cannot use the formula or financial calculator, excuse me, right away. So you have to do some manipulation in order to arrive at the correct answer. This is the situation, and pay attention to the difference between two situations. Is that, excuse me, your annuity is per year and is divisible. Okay. So let's say you are supposed to be receiving $1,200 a year, and it is divisible. So you can say $1,200 a year, $100 a month, that becomes $1,200. $300 per quarter, that becomes $1,200. Or $600 every 6 months, that becomes $1,200. It's divisible. And interest is compounded frequently. It's more than once a year. This is what you do. So this is your situation. Bullet number 1. Your annuity is per year, but it's divisible. Your interest is compounded frequently, more than once a year. It's monthly, quarterly, daily, so forth. Divide annuity C. Divide annuity, that's your C, by M. Divide annuity by M. Divide interest rate R by M. Multiply your period T by N. Everything has to be the same M. If interest is compounded monthly, your C has to be per month, your period has to be number of months, your interest has to be per month. If interest is compounded daily, your C has to be per day, your T has to be number of days, and your R has to be per day. Can you do that? Yes. You can convert your T into number of days or months. R is compounded per month or per day by dividing it by M. And C you can divide by M because it's divisible. They tell you that. What if C is not divisible. What if your annuity is not divisible? That will create a complication. That will create a problem. That is, if the C is $1,200 a year, and that's it, you cannot divide it, but your interest is compounded frequently, you have to be very careful now. The way you handle it is this. You keep your C, your annuity per year. You make sure T is per year. Because C is not divisible, you have no choice but keep it as year. In that case, you make sure T is per year. And what you do for R, you calculate EAR. Do you remember effective annual rate? You take this and you calculate EAR from this formula up here. You take your rate, that's 10%. If it's compounded monthly, you take 10% divided by 12 plus 1 to the power 12 and then minus 1. You calculate EAR. So as the last step, you keep C per year, T is per year. You calculate EAR and you will use it in place of R in the formula or calculate it. You use EAR in the formula or in calculating. And you will be getting correct answer. This is a notation of dealing with a special situation. So write it down. Let me know if you need more time to write it down.
Yes, I need more time.
Okay. Let me know when you're done.
I'm finished. Thank you.
Okay. Anyone else? Also, I will go back to it if you want. I normally do this section of for dealing with loans, different types of loans. I want you to read those. One, we have a pure discount loan. Then we have interest-only loan. And then we have fully amortized loan. I will do examples of these numerical, but the distinction is important. The pure discount loan is probably the most expensive type of loan that you can get because the lender will calculate the interest for you. The lender will calculate the interest for you and then will take the interest, subtract it from the amount of loan, and will give you the check. At the end of the loan, when the loan expires, you have to return to the lender the full amount of loan. This is what I'm talking about. It's a $25,000 loan, 5-year loan at 10%. Okay, $25,000 loan for 5-year loan at 10%. So 10% of 25,000 is 2,500. Okay, it's for 5 years. 2,500 times 5 is $12,500. The lender will take $12,500, the interest of that loan for 5 years, subtract it from the amount of loan, 25,000, and will give you a check for the remaining amount. That is 12,500. So think of it this way. You want to buy a car. The car is $25,000. You go to a bank and they give you discount loan. They say, we give you a loan for 5 years at 10%. You say, okay. They say, all right, 10%, 2,500 a year for 5 years is 12,500. Here is a check for 25,000 minus 12,500 for 12,500. So you have 12,500. They gave you a loan for 25,000, but you get a check for 12,500. After 5 years, you go back to the bank and you pay them how much? 25,000. You pay them 25,000. That's what you borrow. You borrow 25,000. What you got is 12,500 because they collected the interest ahead of time instead of waiting to collect it after 5 years. And by the way, can you buy that car? The answer is no. So if you want to buy the $25,000 car, you have to find out what is 25,000 divided by 1 plus 10% interest to the power 5. That will be the amount of interest. That will be the amount of loan that you have to apply for. So you apply for that amount. You pay the interest ahead of time, right away, and you get the balance as a check. At the end, when the loan expires, you will pay back the bank the amount that you receive because that's the amount you borrow. So the difference is instead of waiting 5 years to pay the principal and interest, you pay the principal now. Sorry, you pay the interest now, you pay the principal 5 years from now. But that means you end up, you receive less money today. So that's a very, very expensive type of loan. Another loan is called interest-only loan, which means you borrow money for a period of time, you pay interest during that period, at the end, you pay the principal. So if you borrow $10,000 at 10% for 5 years, 10% of 10,000 is 1,000. You pay 1,000 every year for 5 years. You only pay interest, you don't pay the principal. After 5 years, you will pay the principal $10,000. This is a loan made to people in order to help them out. If you graduate, you get your first full-time job, you're starting up. So maybe to help you out to buy a condo, to buy a house, the bank says, we give you a 5-year interest-only loan. Why is that? So the idea is this. For 5 years, you only pay interest. After 5 years, you have to pay principal. So you borrow $500,000 at 5% interest for 5 years. So that you pay every year, you pay $25,000 in interest only. Right? For 5 years. At the end of 5 years, you have to pay back the principal $500,000. You say, well, what the heck? I don't have $500,000. The bank says, okay, it's cool. Now, you've been 5 years, you have been working, you're established at your work, you have been getting pay increases. Now we give you a loan for 25 years and you pay it off in principal and interest. In principal and interest. So these loans are called interest-only loan and sometimes are called loans with balloon payment. That's what it means. You pay interest during the period. At the end, you pay the principal. The payment becomes smaller. You're able to deal with it, and then when the loan expires, you refinance it. That's the idea. There. Finally, we have amortized loan when you pay interest and principal periodically. Amortized loan when the borrower pays interest and principal periodically. I will come back on Wednesday and explain that. So we are meeting on Wednesday, and if there is anything to the contrary, we will meet in person next week, starting Monday. All right. Thank you for joining me. I'll be here during office hours if you have any questions, and that's it. You have a nice day. Bye-bye.
Thank you, Professor.
Thank you,
as well.
Professor.
Bye. Thank you.